Okay, now we're going to talk about how to eliminate the parameter. Sometimes it's cumbersome working with two different equations and you'd like to have it just as one equation. Okay, there are two methods. One method is that you solve for t in one of the equations and then you substitute that expression for t into the other equation. So you solve for t in one equation and substitute into the other equation. That's kind of the standard method. A second method that often will work well is first you solve both the equations for t. And then you take the resulting expressions that you've come up with and set them both equal to each other. So I will show you one of each. So let's say we're looking at this set of parametric equations. This is from the first parametric equations example that we did. Okay, so I am going to look at each equation and think about solving them for t. So for this one here, to solve for t, it's not too hard. All I would need to do is add 3, and that would isolate t over here. So I get the expression that x plus 3 is equal to t. All right. Now, this wouldn't be that hard. I would divide both by -2, which would create a fraction, so I'm not going to do it. But you could. So what I'm going to do is go back to the expression I came with here, that t is equal to x plus 3, and then in this equation, I'll substitute that in. So in place of t, I will write x plus 3. So then I'll have y is equal to -2 times the quantity, x plus 3, which I could write as y equals -2x minus 6. And so that's the rectangular equation for those parametric ones. Right? And that was the first equation, first set of parametric equations that we did, and we came up with this graph. And if you look at this graph, it is the line y equals -2x minus 6. There's a slope of -2, and it is going to intersect the y-axis at -6 if it went on. Right. And here is a second equation. All right, so again, I'm going to solve for t. In both of these, it's going to involve fractions. So let's just start here. I will subtract 5 from both sides. So then I'll have x minus 5 is equal to 2t. And then I'll need to divide by 2. So I'll have x minus 5 divided by 2 is equal to t. And I could substitute that into the other one, but actually it's a little bit easier if I go over here and solve this one for t also. So here I would need to add 1 to both sides. So I'd have y plus 1 is equal to 3t. And then I'll need to divide both sides by 3. So I'll have y plus 1 divided by 3 is equal to t. Okay, so I have two expressions that are both equal to t. X minus 5 divided by 2 and y plus 1 divided by 3. So these need to be equal then, since they're both equal to t. So I could write x minus 5 divided by 2 is equal to y plus 1 divided by 3. So I see I've eliminated the parameter. T is gone. Now to first solving this, I could multiply both sides by 3. Right, this is linear. X and y are both to the first power. So I can see it's going to be another equation of a line. So that's why I was going to solve for y. And then I would have 3x minus 15 over 2 equals y plus 1. And this is the same thing as 3 halves x minus 15 halves. And then I could subtract 1. And I'll have 3 halves x minus 17 halves is equal to y, which is in that y equals mx plus b form.